the transport layer services. So in the previous class itself, we looked after the two different types of transport layer services. Okay, so with respect to the service which it is going to or with respect to the type of connection, we have two types of transport layer services. Okay, the first one is connection oriented service and the second one is connectionless service. Okay, so in the connection oriented service, what actually happens? So first thing, the first and foremost thing is the connection is first established. Remember, this is a virtual connection. Okay, so this is not a physical connection. A virtual connection will be established between the sender and the receiver. After the connection establishment takes place, then the transfer of data takes place. So when both the sender and receiver completes the data transfer, at the end the connection will be released. Okay, so in connection oriented services, the service is generally reliable. What is the meaning of reliability? See here, before sending the data, okay, we are trying to establish a connection. That is, we were making sure that at the other end the receiver is present. Okay, so whenever we are sure that the receiver is present and the receiver is able to receive and the receiver is ready to receive, then only we will send the information or data, right? For that reason, we can guarantee the data reliability in connection oriented service. Okay, so there are two different types of protocols which provides this connection oriented service. The first one is TCP, that is transmission control protocol, and the second one is SCTP, stream control transmission protocol. Now coming to the second type of transport layer service based upon connection is connectionless service. So what happens in the connectionless service? The name itself specifies that there is no establishment of connection. That is, the packets are sent from the source to destination without any connection establishment. Okay, we do not check that whether the receiver at the receiving end is ready to accept our information, or we do not make sure that whether the receiver is present at the receiving side or not. Okay, so here we are not making any virtual connection. We wanted to send packets, we will send packets. That's it. Okay, so here the packets are also not numbered, isn't it? So if they are not numbered, obviously what will be the consequence of not numbering the packets? The packets may be delayed, or the packets may be disordered, or the packets may be lost, or the packets may be corrupted. Okay, so if the packets are lost or corrupted or delayed or disordered, there is no provision for us to identify which packets are lost, which packets are corrupted, which packets are delayed, which packets are disordered. Okay, so for this reason, we have to again retransmit the data. Okay, so that is the reason, when as the packets are being corrupted, they are delayed, they are disordered, and they are lost, this connectionless service is called as unreliable type of service. Okay, so now the transport layer protocol also provides one protocol which helps us to do the connectionless service or connectionless communication, which is nothing but UDP, user datagram protocol. So in this session, we are going to discuss completely about the user datagram protocol and a small introduction to TCP protocol. So in the next sessions, we will be discussing about the other parts of TCP protocol. Now, again, we can differentiate the transmission again we can differentiate the transport layer services based upon their reliable service versus unreliable service. Okay, so we can say that the services provided by the transport layer can be either reliable or unreliable. So what actually happens if the application layer program needs reliability? That is, we know we have an application layer here, right? This is application layer, and then this is, let us say, this is transport layer, and this is network layer. Okay, so if this application layer program, if it requires reliability, which protocol should we employ? Can anyone answer? Which protocol should we employ if we require reliability in our application? TCP protocol, right? So we should use a reliable transport layer protocol, which is nothing but the TCP protocol. So why we are going to call this as a reliable protocol means it provides us the flow control and error control at the transport layer. If you remember, we discussed about the flow control and error control at the data link layer also, and in transport layer also we will be implementing flow control and error control. Okay, so when we are providing flow control and error control, obviously the overhead of the protocol will also be increasing. So which means that it is slower and more complex service. That is, if we are adding more features, that is, if we want our protocol to give more reliability, obviously we have to add more number of services. So which ultimately results in a complex service, and the service will be slower because the amount of functionality that that particular protocol has to give us during communication, if the amount of services increase, obviously it becomes slower. Okay, but on the other hand, if you remember, or if you say, if this application program do not need any reliability, that is, it just simply want to send its information to the destination system, it is not going to consider any reliability. That is, at that moment of time we do not require any flow control or error control mechanism. That is, this application layer program itself can see its own flow control and error control mechanism. So at that moment of time, there is no need for our transport layer protocol to provide all these flow control and error control services. So what happens, that then that kind of service will be a fast service. Okay, because that kind of application is not demanding the transport layer to provide flow control and error control, isn't it? So for this particular kind of application, we require an unreliable protocol. So at this, for this kind of case, we are going to use UDP protocol. Okay, and for this kind of case, that is, if the application layer protocol, if the application layer program requires flow control and error control, then we have to use either TCP or SCTP. Okay, mainly and most importantly and most frequently, we are going to use the concept of TCP protocol only, and this is what we are going to discuss also. Okay, so as already discussed, so in the internet there are majorly three common protocols. That is, there are three common and different transport layer protocols. The common means most commonly used protocols are three, and these are different transport layer protocols. That is, they are differentiated basing upon the type of headers they are going to use, basing upon the how many number of fields they are having. Okay, so here UDP, we are going to use the UDP protocol if we require a connectionless and unreliable communication. We use TCP and SCTP protocols if we require connection oriented and reliable communication. Okay, so these three protocols now are implemented in the application, are implemented in our communication basing upon the requirements we have. So if we do not require any reliable communication, we go for UDP, so that the overhead is less. If we require a reliable communication, connection oriented communication, we either should employ TCP or SCTP protocol based upon our requirement. Okay, now we have a question here. As we already discussed that in data link layer, we are using flow control and error control. Okay, so if data link layer is providing the flow control and error control, what is the need for us to again ensure the flow control and error control at the transport layer? Or the question is, should we also ensure the flow control and error control mechanism at the transport layer also, even though we are ensuring them at the data link layer? For this question, the answer is yes. Why? Because reliability in terms of data link layer is between nodes. See, as if you remember, the communication in data link layer is node to node communication, and the communication in network layer is host to host communication, and communication in transport layer is process to process communication, right? So reliability, that is, the data link layer provides reliability, of course, but it is provided only between the nodes, because data link layer is only concerned with node to node communication. But what we are requiring, we require the reliability between node to, between the ends, that is, between the source to destination. The source to destination delivery or source to destination reliability is not considered by the data link layer. So obviously we need reliability at both of these ends. Okay, so for this reason, we need to have error control and flow control at the transport layer also. Okay, also, so if you see in the network layer, we are going to use a protocol called IP, that is internet protocol, isn't it? So this IP protocol is also connectionless protocol only. Okay, it is unreliable protocol. This IP protocol is also unreliable protocol. So when this IP is unreliable protocol, obviously we need some protocol on top of this protocol which provides us the reliability. Okay, so for this reason, even though we are having flow control and error control at the data link layer, we are forced to use the flow control and error control at the transport layer also. Okay, so is it clear, all of you? Guys, am I audible?
Yes, sir. Yes,
Okay,
sir.
okay, 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 okay. Next. So if you see here, this diagram tells us about the discussion which we had just now. If you see, this is our data link layer and this is the physical layer. Okay, so from node to node communication we have flow control and error control with the help of data link layer, this one, and from this node to this node. Okay, but this is our source actually, and this is our destination. The source to destination flow control error control is not done by the data link layer. So here, from source to destination delivery, the error and flow control is not checked. Okay, it is not checked by the data link layer. For this reason, we obviously require flow control and error control at the transport layer also. So now in the transport layer, actually the flow control and error control is implemented by using a protocol called TCP protocol, and this TCP protocol in turn implements this concept with the help of sliding window protocol. So in the data link layer, we looked after sliding window protocol, right? So here also we'll be discussing about how TCP is going to ensure the flow control and error control. Okay, do remember in transport layer we have three protocols. The first one is UDP protocol, the second one is TCP protocol, and the third one is SCTP protocol. UDP protocol is connectionless and unreliable protocol. Okay, this is what you have to remember. So in transport layer, to provide reliability, to provide flow control and error control, we use which protocol? TCP protocol only. UDP protocol does not provide any flow control or error control. Okay, so this is very important point you have to remember. Next. So as we told, there are three protocols. Okay, so what are the three protocols? TCP, I mean, or TCP IP protocols, what you can call it as. Okay, so we have UDP protocol, TCP protocol. Okay, and then we have SCTP protocol also. So first of all, we'll discuss about UDP protocol, and then we discuss about the TCP protocol. So if we observe here, these are the different types of protocols which are available in the layer. See, in the physical layer and data link layer, we have some LAN and WAN technologies. Okay, so coming to the network layer, the main important protocol which is used in the network layer is IP, Internet Protocol. Okay, so this is IP, Internet Protocol. See, on the top of the network layer, we have transport layer. So we have UDP protocol. This is the TCP protocol, and this is the SCTP protocol. If you remember, network layer is going to provide services to transport layer. Okay, transport layer will provide service to application layer. So in the application layer, we have different types of applications. Okay, so about this application layer, we'll be discussing in our future classes. Okay, we are now concerned with the transport layer, right? So here we have UDP protocol, TCP, and SCTP protocol. Here the network layer is going to provide the services to the transport layer. That is, here IP protocol is also connectionless. It is going to just provide the best effort delivery. That is, it will try its best to send a particular datagram to the destination without any problem, but it does not ensure it does not ensure that it is sent without any problem. So for this reason, on the top of IP, actually we have this TCP protocol. So this TCP protocol in combination of IP, okay, is going to ensure that the receiver is going to receive the data correctly and within particular order and so on. Okay, so first we'll be discussing about UDP protocol. So before discussing about this UDP protocol, first of all, we'll see what are the different duties, or what are the different services, or what are the different functions which are provided by the transport layer. The first and foremost duty of the transport layer or service or a function of transport layer is establishing, maintaining, and releasing a connection. As already told initially, before data communication, first the connection must be established. The second one is connection must be maintained properly for communicating the data or information from from source to destination. And the third thing is the the connection has to be released. Okay, so this is the first thing. The second thing is addressing. So we already discussed about this addressing concept, right? So addressing in the transport layer is done in the form of what? Port numbers. Okay, each and every process is identified with the help of a port number. And the next one is data transfer. That is how actually the data transfer is going to take place. And the fourth duty is flow control. That is transport layer has to provide flow control. And fifth one, it has to provide error control. And sixth one, it has to provide congestion control. So we are going to discuss about all these different duties provided by the transport layer as and when the concept comes in our context. That is basing upon our context, we are going to discuss about how all these functions are being provided by the transport layer. But for now we have discussed only the concept of addressing. That is how addressing takes place in the transport layer, okay, using the port number. So we have to discuss about all the other things, okay, how data transfer, flow control, error control, and congestion control takes place. So we'll be discussing as and when our discussion demands us. Okay, so let us now first discuss about the easy protocol and very simple protocol called user datagram protocol. So which is called as UDP, user datagram protocol. So right from the inception, we are going to make it clear that UDP or user datagram protocol is a connectionless protocol. It is an unreliable transport protocol. That is, do remember, very important, it is connectionless and it is unreliable transport protocol. So what is the meaning of this one? It is not going to add anything to the services of IP. So previously, if you see this diagram, I'm just going to clear this for better understanding. So if you see here, this is our IP protocol. See, whenever data comes from the top, okay, at the sender, data comes from top to bottom, right? In this manner, and at the receiver, data goes from bottom to top manner. So when the sender sends the information, it has application header along with the application data. And now at the transport layer, this complete thing will be the data at the transport layer, and transport layer adds its own header, right? And now coming to the network layer, this complete thing will be the data part at the network layer, and it adds its own header, right? Okay, so now why we are discussing this means, if you see in the user datagram protocol, this UDP protocol will not add anything to the services of IP. That is, see, the data will be coming from application to transport layer and transport layer to the network layer. If we are going to use UDP protocol at the transport layer, now after adding this to the header, now the packet will come to the network layer. Now the network layer header will be added. That is, the IP header will be added here. Okay, but even though you are using the UDP protocol, this UDP protocol will not add any kind of reliability to the packet which you are sending. That is what it is being said here. That is, UDP protocol will not add anything to the services of IP. But what does it do? Except it provides process to process communication. So how UDP is going to enable the process to process communication means, the UDP protocol is having a header. Okay, so basing upon that header, we are going to provide process to process communication instead of host to host communication. If we are dealing with only up to network layer, we have host to host communication, right? But if we are working with the transport layer, then we have process to process communication. So to enable process to process communication, what do we require? We require port numbers. Okay, so we'll discuss how UDP is ensuring process to process communication using port numbers just after 1 or 2 minutes. Okay, next, other important thing is that UDP is not going to perform any error checking. It performs only a limited error checking. So why it is performing only a limited error checking means, this also will be making it clear when we have that discussion. Okay, now, so the first thing is that UDP is so powerless. As we already told, UDP is connectionless. UDP is unreliable, right? So for this reason, the UDP protocol is not having any power. Okay, so if this UDP is so powerless, then why would we want a process to use this UDP protocol? Isn't it? Obviously, right? If there is no use with a protocol, why do we ask to implement that protocol in our communication? Okay, don't worry. Obviously, there is some advantage with the disadvantages. Okay, so when you see something, when you see some five-star ad, right? Just eat, do nothing. See, he will be only eating that. Old lady will ask him to give that stick, okay, but he will not respond. So soon after that old lady get out of that bench, what actually happens, okay? So from the top some concrete material will be falling down, okay? So that particular guy not doing anything saved the life of that old woman, isn't it? So here also having some disadvantages has come with some advantages. So let us see what actually happens there, okay? So the first thing is that the first advantage is UDP is a very simple protocol. Why? As we already discussed, it does not provide any connection and it does not provide any reliability. So obviously the overhead is minimum. Okay. So now if the process wants to send a small message, okay, and if that particular application program is not caring about any reliability, then it can use UDP. So obviously there are many requirements for us to communicate from one place to another place. All the time we do not send only large messages. Sometimes there is a requirement for us to send only small messages. So if we are going to send small messages, why to have much of the overhead? So for this reason only, mainly we are going to use UDP protocol. That is, if we do not require any reliability at that moment of time, okay, we can then use the concept of UDP protocol. Okay, so here in UDP, we are going to send the packet in small datagram, that is in the small packets. So now we are going to send the message in the form of small messages with the help of UDP. So what happens here if we are sending the small messages with the help of UDP? Okay, so there will be less interaction between the sender and receiver, obviously, isn't it? Because there is no connection establishment, there is no connection release. Only the simple thing is data transfer, and that too unreliable data transfer. That is, if the application requires unreliable data transfer, then it will use obviously UDP. So as the overhead is low, it is very easy for us to use this protocol in our communication. But the only drawback is that it is not used when application program requires reliability. Okay, so if you see here, communication happens in UDP with the help of port numbers. This is what we have discussed, right? So in the previous class we discussed about some well-known ports which are identified by IANA organization, right? So these are all the well-known ports which are used by UDP. Port number 7 is used for echoing. That is, it whenever the a receiver receives, okay, a particular datagram, so it again receives this, it again echoes this datagram to the sender back. Okay, so port number 9 means it is going to discard the datagram. Port number 11, it is going to list out all the active users. Okay, port number 13 tells about, it returns the date and time of a particular time. Okay, at that particular moment of time during that request, what is the current date and time. So like this for all these port numbers. Okay, so we are having, these are the well-known port numbers, that is for a particular purpose, that is for RPC. Obviously the port number should be only 111. For NTP, network time protocol, the port number should be 123. These are fixed. For this reason only we are going to call them as well-known ports. So these are all the different port numbers used by UDP for different types of requirements. Now, coming to the user datagram. So in UDP, the name itself specifies UDP means user datagram protocol. So in UDP, we are going to call those packets as datagrams. Okay, when we are talking about UDP protocol, we'll talk about those packets as datagrams. Okay, so what does this datagram consist of? They have fixed size headers, and this header is of 8 bytes size. Okay, we told that UDP protocol is going to add some header. Okay, isn't it? So what is this header? Okay, so this header is used to specify different types of information. Okay, this is obviously the data and this is the header part. So this is how many bytes long? It is 8 bytes long. Okay, so what does this header contain? The header contain 4 parts: 1, 2, 3 and 4. These are 4 parts. What is the first part? Source port number. How many bits length it is? 16 bits. So what is the source port number? Obviously this is the sender and this is the receiver. So when sender is sending the information, okay, to identify the sender process, okay, the sender has to send this particular port number, because when the receiver wants to again reply back, it can only reply when it know the port number of the source, isn't it? For this reason we have source port number which is 16 digits. Okay, So, what does this mean? If it is 16, if it is 16 bits, it can say that the port number can range between 0 to 65,535 numbers. Okay. So, if the source host is the client, okay, if the packet is now coming, let us say if this is client and this is server. Okay, so if the source host here is client, obviously it is going to use what type of port numbers? It is going to use ephemeral port numbers only, that is temporary port numbers only, isn't it? But what if the source host is a server? If the source host is a server, the port number in most of the cases will be a well-known port number. So you came to know the difference, right? If the source is a client, it can choose this port number from 0 to 60. I mean, it can choose this port number, it can choose this temporary port number. If the source is a server, it can choose its port number from the well-known port numbers only. Okay. Next, the second one is destination port number. Okay, so the destination port number is the port number which is used by the process which is running on the destination host. So here we have another process, right? So this is the destination port number. It is also having 16 bits. Okay, so if the destination host is the server, then the port number will be again well-known port number. If the destination host is the client, then the port number will be again a temporary port number. Okay. The next part is total length part. Okay, so this length part is also 16-bit field. So this length part defines the total length of the user datagram, that is the complete length of the user datagram, that is header plus data part. What is the complete length of this particular datagram? It is going to specify. Okay, the last thing is checksum. So what is checksum? So the concept of checksum is it is used to calculate about some errors. Okay, so here what we are going to do, we are going to calculate some errors. So in the starting itself we discussed about some important point, that is UDP performs a limited error checking. Okay, so this limited error checking is carried out by this checksum field in the UDP header. Okay, so this is the header format of, so this is the header format of the UDP protocol, that is it contains source port number, destination port number, total length and checksum field. Next, let us now discuss about the UDP operations. The first operation, obviously we know that UDP provides connectionless service. Right from the starting, we are discussing that UDP provides a connectionless service. So connectionless service means every datagram which is sent by the source is independent of the other datagram. So let us say this is source and this is destination. Okay, the datagram, let us say if one datagram is following one path, okay, there is no guarantee that the other datagram also follows the same path. Okay, so the second datagram may follow this path, third datagram may follow this path, fourth datagram may follow again this path, and so on. That is, every datagram which is sent by the sender using the UDP protocol is an independent datagram. Okay, so there is no restriction onto which line that particular datagram has to reach the destination. The UDP datagram can take its own path, can take its own independent path. Okay, so as there is no relationship between the different user datagrams, okay, so there are some advantages. That is, let us say this is source and destination, there are different paths from source to destination. If a particular user datagram takes this particular path, okay, let us say there is a congestion. Now there is an advantage for this user datagram. Now it can go at this particular connection because there is no congestion here. Okay, so this is the advantage. Okay, and another important thing is that there is no relationship between one datagram and another datagram. Let us say if you are going to send an information called hello. Okay, so first you have sent H. Okay, even though here at the source H, E, L, L, O are related to each other, but during the transmission H is not related to E, E is not related to L, L is not related to the next L, O is not related to the previous L. That is, there is no relationship between one datagram and the next datagram. Okay, even though they are going to the same destination, even though this hello information is going to the same destination, in transit these datagrams are not going to have any relationship with each other. Okay, And the next thing is, as already discussed, the datagrams are not numbered. Okay. Also, there is no connection establishment and there is no connection termination. But in TCP, it is not the case. When we discuss about TCP, we'll see what is connection establishment and what is connection termination. Okay. So as there is no connection establishment and connection termination, what does this mean? Obviously, every datagram can travel its own path. That is, they can travel in the different paths. So due to this connectionless feature of the user datagram protocol, we have a consequence. That is, as a consequence of being connectionless, what actually happens, the UDP cannot send stream of data. That is, stream of data means continuous data. Do remember, UDP protocol cannot transmit continuous data. It can only transmit small chunks of data which are called as datagrams. Okay, so if you wanted to send stream of data, that is continuous amount of large amount of data, you cannot use UDP protocol. Okay, so if you want to send large amount of information, what you have to do, as you cannot send it large amount of information, you have to break down this information into chunks, or break down this information into break down this information into some parts. Okay, so these are called datagrams. Okay, so only the applications or only the processes or only the programs which want to send the short messages only can use UDP. If the application program want to send large messages, it cannot use UDP protocol. Okay, next. Next, about flow control and error control. So as already discussed, UDP is a very simple protocol and it is unreliable transport protocol. Why we are calling UDP as unreliable transport protocol? Because there is no flow control and there is no error control. So if there is no flow control, obviously there is no concept of window mechanism. If you remember in the data link layer, when we are discussing about transfer of data from source to destination, we discussed about windows, that is sender window, receiver window. Why we are maintaining the concept of windows there? Because we are implementing the concept of flow control there, right? So here UDP protocol is not going to support any flow control, so obviously there is no concept of window mechanism. Also, there is no flow control. As a consequence of this, there is no window mechanism also. So as there is no flow control, what happens, the receiver may overflow with the incoming messages, obviously, right? When there is only flow control, then only the receiver can tell the source to send the messages in particular order, or it can tell the sender to wait for some amount of time because it cannot process the incoming message. But when we are using UDP protocol, as there is no flow control, the receiver may be overwhelmed with the messages which are coming from the sender. Next, coming to the error control, obviously there is no error control mechanism in UDP except for the checksum, as we have discussed in the previous slide. Only the checksum is the kind of error control mechanism. Other than checksum, UDP protocol is not going to employ any error control mechanisms. That is, if the sender is sending some information, the receiver has no provision to know whether the message has been lost or whether it has been duplicated. Okay, so as UDP protocol provides some kind of error control using only a limited amount of error control using checksum. So when this receiver is going to detect the error, when it finds the checksum, or when it calculates the checksum, then the user datagram will be silently discarded. Okay, so this notification also will not be given to the sender. Okay, so finally, the lack of this flow control and error control mechanism means the processes which are using UDP should provide these mechanisms. Obviously, right? So when there is no flow control and when there is no error control, which is not that is when UDP is not providing flow control and error control, the applications which want the flow control and error control, which should enable the flow control and error control by themselves. Okay. The next thing is encapsulation and decapsulation. So to send a message from one process to another process, what it is going to do, UDP protocol is going to encapsulate the message, isn't it? So if you see here in the starting, I'll just show you in this diagram. I'm just going to clear this. So when the sender is going to send the information to the receiver, what it is going to do? If you are using UDP protocol here, so the UDP header, and I mean the transport layer header, which is using UDP protocol and the data. Now this data will be done what? It is encapsulated in the network layer data part, and the network layer is going to add some its own network layer header. Okay, so this part is what we are going to call it as encapsulation. That is the process of placing the header part and data part of the upper layer into the data part of the next layer, lower layer, is called encapsulation. At the receiver side, what happens again? Now from this complete data part consists of header part and data part again. So again, this data part consists of header part and data part. So the process of removing the header and data part from the data part of the lower layer is called decapsulation. So UDP protocol here also does some encapsulation and decapsulation. Next concept is queuing. Okay, so in UDP, the ports, so communication between process to process happens with the help of port number only, right? So here in UDP, the ports are having some queues. That is, queues are associated with ports. So let us see why queuing mechanism is required when we are discussing about the process to process communication. So if you see here, we have a process called daytime client process. That is, it is going to request the date and time at that particular moment of time. This is the daytime server process. Okay, so here we have two types of queues: outgoing queue and the incoming queue also. Okay, so let us now discuss about what are these outgoing queues, incoming queues, and the different kind types of things on the diagram. So first thing, let us now first discuss about the client side part. So at the client side, what actually happens whenever a process has started? So obviously, to identify itself, what it is going to request, it is going to request a port number from the operating system. So the operating system is the one which is responsible for assigning a port number for a particular process. Okay, so obviously, some implementations may have only one queue. Okay, and some implementations have two queues. That is, first queue will be outgoing queue and the second queue will be incoming queue. Okay, now, so if a particular process wants to communicate with other process, that is, if one process wants to communicate with one process, or if one process wants to communicate with more than one process or multiple processes, okay, but this source process is going to get only one port number. Okay, so do remember, this source process is going to get only one port number. Okay, and it is going to use only one outgoing queue and one incoming queue. That is, even if this process is going to communicate with multiple processes, it is going to get only one port number and one outgoing queue and one incoming queue. Okay, so if you observe, right from our initial discussion, we are saying if the process is in the client side, obviously that particular process is identified by the ephemeral port number, that is temporary port number. Okay, if you see, I'm just clearing this one. So this is our port number 52,000. So this is the temporary port number because we are dealing with the client side. The process is in the client system. Okay. So now how up to what time these queues will be residing in the memory? So the queues function as long as the process is running. So until and unless the processes are running, the queues will not be destroyed. After the process completed or after the process terminates, the queues will be destroyed. So this is all about the queues in the client side. Okay, now what happens at the client process at the client side? Now it tries to send the message to the outgoing queue. Okay, so all the request will be placed in this queue. That is the first block, second block, third block, fourth block, and so on. Okay, so now the client is going to use this source port number. What is the source port number? 52,000. Okay, so it is going to send the message by placing them in the outgoing queue. Okay, now what this UDP at the center side will do, it removes the messages one by one. Okay, it is going to remove the message one by one, and it is going to send this particular request to the destination. So one by one it is going to remove and it is going to send this one. Okay, So here the outgoing queue can overflow. Okay, so why? Because we do not provide any flow control, right? So here the outgoing queue can overflow. So if this happens, okay, what actually the operating system will do? The operating system will tell the client process to wait before sending other messages. Okay, so if it is going to send the request one after the other, one after the other, one after the other, obviously it will be having only a limited amount, right? So obviously the queue will be overflowing. So now operating system will send an interrupt to this process. Okay, process please wait because the queue is full. Okay, so this is about the queues in the client side. Now coming to the queues in the server side, it is that is creating queues in the server side is somewhat different when compared to the client side. So what it is doing, the server is going to ask for incoming queues and outgoing queues. So here in the client side we identified a process with the port number 52000, which is an ephemeral port number here, but we have used port number 13, which is a well-known port number. Okay, so here also the queues are going to remain in the memory as long as the server process is running. Okay, now, so when a message arrives at the server, that is now from the outgoing queue of the client, this message will be coming to the incoming queue, right? So when message comes at the server, now the UDP protocol at the receiver, that is at the server, is going to check whether the incoming queue is having a particular port number specified, because it is sending a request with the port number 13, right? If this port number 13 is present here, okay, if that port destination port number matches with the port number which it is sending, okay, then it is going to service this particular request. Okay, if it is not going to match, then it is going to discard that particular service and it will be sending an error notification to the sender. Okay, so this is how the communication actually happens using the incoming queue and outgoing queues. So if that particular queue is not present, that is if that particular number 13, here actually this server process is identified with 13. But if it is sending a request with some port number 14, okay, then it is going to tell that this particular port number 14 is not available with me, and it asks this ICMP protocol, that is Internet Control Message Protocol, to send a port unreachable message. That is, okay, client, you are asking some information to me with the port number 14, but I am at my process is residing at port number 13, so you cannot reach me with this particular port number, so this information will be sent to the client. Okay, here also the incoming queue can overflow. Okay, again if this happens again, it is going to drop the messages and it is asking for the port number unreachable message which is sent to the client. Okay, so like this is how the working of queues will happen in the UDP protocol. Okay. Now the last thing is uses of UDP. So let us now see what are the uses of UDP. The first thing is that as UDP protocol is very simple protocol, it is suitable for request response type of communication. What is request response type of communication? Simply we'll send a request from client to server. Okay, the server is going to simply respond. Okay, so if you type something www.gmail.com, okay, then what is that you are sending? You are sending a request to the server. Now the server is going to respond to your client by sending that particular page, isn't it? So this is what we are going to call request response communication. So if you see here, when you are using this request response type of communication, even though your request did not reach to the server, what you will do again, what you will do, you will press on refresh button, right? So what you are doing again, you are again sending a request. Okay, so at this moment of time actually you do not require any reliability kind of thing. Okay, here we are sending only request. Okay, if the server does not respond, what you will do, you again send the request for the second time. If it is not going to respond, what you will do, you again send the request. Okay, here there is no requirement of any reliability. Okay, so at this kind of applications we'll use only UDP. So what will be the problem if we are going to use TCP at this particular moment of time? So first of all, what it has to do, it has to establish a connection, and then it has to send the data, and then it has to terminate the connection. So for this small kind of request response communication, if you use TCP protocol, obviously it is a waste of network capacity, then obviously the request will be also a complex thing. So for this reason only, the client server communication, okay, or the request response communication is always going to use UDP protocol. Okay. Next, UDP protocol is suitable for processes which are having their internal flow control and error control mechanism. That is, if the application layer is going to provide its own flow control and error control, there is no need for us to provide again the flow control and error control at the transport layer. Okay. So one such kind of protocol is that TVFP, trivial file transfer protocol. It includes its own flow control and error control. So this can use UDP protocol. Okay. So this can use UDP protocol. So the next requirement, the next use of UDP is UDP is a suitable transport protocol for multicasting. Okay, so whenever we wanted to do multicasting, the UDP software is very much useful for us. This is not possible with the TCP software. Okay, next thing is UDP is used for management purposes also. That is network management also. SNMP that is simple network management protocol. So in simple network management protocol also we are going to use UDP protocol. Okay, and UDP protocol is also used in the routing protocols called RIP, that is routing information protocol. So now RIP uses UDP, SNMP uses UDP, and also TFTP uses UDP. So when we discuss that UDP is not going to provide any connection, it is a connectionless protocol and it is unreliable protocol. But if you observe, there are many advantages of this connectionless and unreliability also, isn't it? So we use UDP protocol when we do not require any reliability from source to destination. So if you want a communication to be simple, okay, so if you think that if my communication does not reach the server or the destination, I can again simply send again the request. Okay, at that moment of time we can use the concept of UDP protocol. Okay, so with this we have completed our concept of user datagram protocol. Okay, so in the next class we'll be discussing about the transmission control protocol. Okay.